I'm in front of a microphone and mumbling. That's terrible. Hello, my name is Steve Elzy. I'm with KRML Radio and your Sanctuary Television. I want to welcome you all to the sixth annual Whale Fest Monterey. And once again, we are following a day of spectacular speakers with another day of spectacular speakers. And coming up next is Jim Vanderzwann. Jim, as you probably know, and maybe you don't, I don't know, he served as a chief meteorologist, lead forecaster for KSBW television for 32 years. And of course, he's certified by every meteorological association in the world, probably the universe. And he's going to talk to you about climate. How's that sound? Please, a warm Whale Fest welcome for Jim Vanderzwann.
Well, good afternoon, folks. I'm one of the few guys that doesn't know any whales personally, but I love them. I think it's great, and I thought, why not be part of Whale Fest? It's a fun thing, and kind of a neat thing that you start to see when you listen to what Greg was just talking about, how everything is interconnected. You know, you mess around with one little element here, and it's going to ripple down the chain and affect something else down the line. Well, the same thing kind of happens with weather in some degree or another, and that often befuddles a lot of people. They wonder why things happen the way they do, and are they connected to something else? Sometimes they are, sometimes they aren't. Recap on weather. The sun that came up this morning, that's your engine that drives it here for the planet. 93 million miles away, the sun provides the energy that heats this planet. If we were a big flat surface, as we once thought Earth was, it would be a totally different environment. You wouldn't have weather moving around the globe. But because we are at a 23-degree angle, we are 4/5 water, part of it's land, part of it's desert, part of it's trees, part of it's ice on the northern and the top and the bottom, you might say. And we revolve around that sun in an orbit that takes about a year. All of that plays into that, and the rotation of the Earth and the spin of the Earth and the motions, the gravity, all of that really impacts how weather operates. Now, that makes it a little bit tough to predict weather sometimes, because if it was possible to reduce a globe, say, for instance, into a box and put in some water vapor and some salt spray and some dust from the desert and give it a spin and put a bright light on it, you could see where everything was going to go, where the storms are going to form. But it doesn't work that way because of gravity, and that comes from the center of the planet more or less, and magnetic fields also play into it, and the changes in the sun's pattern and the sun's light and its energy also impact everything. Along with that, what also impacts the weather is the oceans. There's so much water on this planet, and there are so many currents that flow around these oceans that when they change direction or intensity or temperatures begin to change, that also affects the sky above it. That sky that has that weather is not all that big a deal, really. If you were to reduce the planet to the size of an apple, it's about as thick as the skin of the apple. So the troposphere, that first layer of the atmosphere where most of the weather occurs, it can fill up pretty quickly. But there's a neat mechanism that makes all this work, in that we have the northern hemisphere, we have the southern hemisphere, we have oceans, we have land masses, and we have above that, we have pressure systems that develop in the atmosphere, high pressure, low pressure. High pressure typically is sinking air. Low pressure is rising air. And nature loves to try to maintain a balance with things. So there are times that as one thing moves up, something else goes down. Vice versa. It keeps that balance, all within that troposphere pretty much. So you get this flowing pattern. And you kind of see how that is duplicated in other parts of our planet by the way water moves and the way it circulates and the way the oceans move, and all of this is all interconnected to these principles of physics. And years ago, nature decided to come up with a plan to make it possible for other creatures to live on this planet. It's called the hydrological cycle. And what happens is you have evaporation, condensation, and precipitation. The only element that was left out of that equation was distribution. And as a result, you get floods and you get droughts, and you get areas that get either too much of one thing for too long or not enough of another. But that's part of the natural process, but it does change. Now, this hydrological cycle only works because water is the one substance known to man that can sustain itself in 3 different states at the same time in the same place. I could put a glass of water right here that would have all 3 forms of water in it. One would be the solid, which is the ice. One is the liquid, which is the water. And then surrounding us all right now is the water vapor. That's the gas form of water. Luckily, we have that, because if it weren't for that and we had only liquid water on this planet, we'd all have to wear those yellow rain slickers all the time. And it gets a little old after a while because everything would be stinking wet all the time. But because nature can take that water vapor and it's lighter than air and move it and transport it, that way we can take it and eventually put it somewhere else where it might do some good. Sometimes it's out over the oceans, sometimes it's out over the land. And when you can take that water vapor at a parcel of air and lift it up a mountain, say for instance, or at a layer of warmer or colder air, as you get a boundary of between a high pressure system and a low pressure system, you get winds aloft that scoop it up. As it cools, that water vapor condenses, much like that glass gets that water to condense on the outside of it. You see sometimes water on the outside of the glass. The glass isn't leaking, it's just condensation, and it's changing because of the temperature. Leave it there long enough, the ice suddenly becomes liquid. Leave it there next week, it's all gone. It's evaporated in this thin air. Well, that process is what creates weather as we know it. That's what makes clouds. But we know that most clouds don't always produce rain. But now you have to get really complicated because you also have to add nucleus for snowflakes to form. By and large, in the middle latitudes where we live, between say 30 north and or 30 south and 60 north in the latitudes, that's a west to east flow around the northern hemisphere, duplicated in reverse of the southern hemisphere. Above that, east winds blow in the Arctic and also in the tropics. Go to Hawaii, typical winds, for instance, are from the east. That's again nature maintaining that balance. So what happens is you get normal circulations that develop over time. You get high pressure areas that tend to be predominant a good part of the year, also conducive to making up your climate. Other areas have low pressure systems for most of the year. There's a vortex up over the north, the Arctic. It's called the vortex, and then it just spins around. It's a low pressure system. Not a lot of snow up there because it's so cold and there's not much moisture up there, but it's cold enough to support the snow and ice that's there. You warm it up, things begin to change. In our part of the world, we have this California current that you heard alluded to here, and that's been a big part of why we get all the sea life out here. And that typically develops because high pressure, if this is the coast here, high pressure develops, and that's a clockwise rotation. And the winds move down the coast, which is not this way, it's that way. And that causes this change of current, and it causes upwelling to occur along the California coast. As the waters cool, that determines sometimes what kind of sea life follows with it as well. It also determines what the normal weather is. That's why when you jump in the water in the Monterey Bay in July, it's still colder than the blazes, normally. This last summer, it wasn't so. Typically, even in July, we can get sea surface temperatures in the bay 57, 59 degrees, maybe 60. This year, it was all the way up to 69 degrees. That's as warm as it often is off the coast of San Diego. So one reason was we didn't have that high pressure in its normal place most of the summer. So we didn't have the normal sea breezes that occur. The land sea breezes that occur as, again, maintaining balance as hot air rises out of the Central Valley in the interior of California, it creates a pull to move air in so people in Fresno aren't without something to breathe by dinner time. And that, as that cool air moves over that cold water, it condenses. There's water vapor being pumped into it from near the ocean, and that condenses and becomes a stratus cloud. That becomes the fog that we're so famous for. That's why you can buy sweatshirts in San Francisco and Monterey in summer, where everybody comes from anywhere else in the country in shorts and flip-flops and a t-shirts going, why am I freezing out here? That's a bit the normal pattern there. This summer was remarkably different than that. Even the locals noticed it because we didn't have that strong sea breeze every night. We didn't have that much fog at all, and the sea surface temperatures being warmer get a lot of the credit for that. So what is that about? Is that about El Nino? No. El Nino, of course, has been bandied about a little bit of late, particularly in the news media, but it's not really a new invention. This actually was noted many hundreds of years ago off the coast of South America when fishermen would go out to sea and go looking for the fish that they typically would get. Mind you, of course, in December, that's their summer, so it's a good time of year to go fishing. And a lot of times they suddenly started to notice the fish weren't there, or they were getting different kinds of fish. And it became to be determined that at that point, when they didn't have that pattern, that something had changed. And it happened in December around the time of Christmas, which is Christ, they called it El Nino. That's where the name came from. And it wasn't until hundreds of years, well, decades later, before they really started tracking this. And of course, at that time, we didn't have a lot of ways to measure that. We didn't have satellites up in space. We didn't have buoys all over the Pacific Ocean, the largest ocean in the world. But over time, that did come to be. And we started noticing patterns changing and weather changing well up in the northern hemisphere as a result of this change in the pattern. They later came to find out that when it changes at one end, particularly on the eastern Pacific, off the coast of South America, something changes at the other side of the ocean. And they get less rain than they typically would have had. And they get cooler waters. And they also noticed that high pressure and low pressure systems that were typically in place revolved and changed places. And it became the El Nino Southern Oscillation, or an ENSO event. And more science was developed into that. And when it really got to punching us pretty good here in the West Coast in 82 and 83, they really said, okay, we got to figure out what's going on here. So they put this whole network of buoys out there in the ocean. And of course, at that point, we've already had some satellite data that could help along a little bit. And now more and more sophisticated satellites came into play that could measure the sea surface temperatures. Because you got to figure the buoys offshore are usually within 50 to maybe 100 miles. And with the distances involved across the Pacific, there was very little down there along the equatorial Pacific or off the coast of South America to give us much of a reading on what was happening with the ocean. As it happens, NOAA and NASA are organizations and lots of others that have gotten together with all sorts of scientific equipment to now measure that ocean. And NASA has a satellite that can actually see the height of sea surface from one end of the Pacific to another, a matter of inches sometimes, by measuring how warm it is. Well, you've all over the years seen the pictures of the globe there, and there's North America and South America, and there's this big orange, red-orange thing going out in the middle of the ocean. That is the El Nino. That indicates that we have this strong, warmer than normal temperature. Now, it doesn't take it from 60 degrees all the way up to 90 degrees, but a matter of a couple of degrees Celsius can make a big difference. It makes a big difference on the Earth's climate, which can vary about 5 or 6 degrees Celsius, maybe 8 or 10 degrees Celsius, difference from one extreme to the other. Same thing with the sea surface temperatures. And like everything in nature, not everything is black and white. People often come up to us, people who try to guess the weather and say, is it going to rain tomorrow? Well, yes or no. Maybe a part of the day, sometimes. It's a rare event when you have a rain that goes on all day long that stretches all the way from Redding all the way down to Santa Barbara. That's a pretty massive winter storm. That's a slow mover. Takes all day to get across the sky. Those don't happen all the time. When you have that, you say, yes, it's going to rain all day long. Most of the time, it's not quite that definitive, or it's an event that moves quicker. It's a smaller cold front, covers part of the state, moves from north to south. You can see it on the satellites on TV. We show you all that all the time. Behind it, there might be cold air that also is lifting that water vapor and creating those beautiful little puffy cauliflower clouds around here that become what we call cumulonimbus clouds, showers and thunderstorms. And that's what always messes people up. They say, well, you said it wasn't going to rain, but I got wet. No, we had a chance of showers. And you call your buddy down the street 2 blocks away. What rain? I didn't get any rain. But you look at the radar, you see these little green blobs marching along. They suddenly just pop up out of nowhere as the cloud begins to develop. It gets enough energy in it. Eventually lets go with the water, and it moves out and away and dissipates. And all of that is impacted by the movement of air masses that are colder and warmer in relation to each other. Now, when you add a mix of warmer water in a part of the world, that begins to change things a little bit. It doesn't necessarily change the temperature of the Monterey Bay, because that's a long way away. Off the coast of South America, El Nino generally doesn't have a direct effect on the water off the California coast. But as it becomes so strong as it has this time, in 97, 98, it was stronger than it was in 82, 83. It is now the strongest that we've ever managed to measure. It is way up there. And when you rank it on a scale of about 4 levels, it's right up at the top. So that means, okay, we've got an awful lot of very warm water off the equatorial Pacific. So now all of a sudden the news media says, oh my God, we have a Godzilla El Nino out there. Well, let me tell you that El Nino has no relation at all to Godzilla. If the creature ever existed, he wouldn't be coming around here, and it has nothing to do with the weather. They like to sell tickets to the show, but that really has nothing to do with it. Scientifically speaking, it is a very active, full-fledged, full-blown, full-blossoming El Nino with warm sea surface temperatures. That's all it is. And people say, when is the El Nino storm going to get here? And that just drives me crazy, because I can show you satellite pictures of the entire globe, And I guarantee you, you will not see a big storm looming somewhere over the Pacific. Big green blob filled with rain that eventually the wind is going to blow it and it's going to come right over your house and let go with a ton of rain. Nope, ain't going to happen. It could make for great movie making, but it doesn't happen that way. Simple fact of the matter is there is no such thing as an El Nino storm, because El Nino refers to the warming of the sea surface, and it goes into the depths of the ocean, and it impacts the pressure patterns out in the Pacific. That's all it is. But what it does do, the warmer the water, the more water vapor will go there. Fundamentals of weather: warmer water holds more water vapor. Simple example is you go to Monterey in July. People come from somewhere else on the other side of the Rockies and say, boy, this is nice. You guys don't have any humidity here. Well, I can show you we have plenty of humidity, particularly in July, actually. We have 80% humidity by the time we get to 5 o'clock in the evening oftentimes, but the temperature's only 60 or 65 degrees. The air mass is close to being saturated because the fog is right over your head, only 200-300 feet above your head. But your body says, you know what, at 60 degrees, that much water, it feels cold. I'm going to go buy a sweatshirt. But you do that same trick in New Orleans, where the temperature is maybe 85 degrees, and the relative humidity is about 80%. Now all of a sudden, you don't want a sweatshirt. You step out of your air-conditioned hotel and take 4 steps forward on the street, and you're standing there perspiring like a stuck pig. That's because the air mass is so saturated, but it is so warm, your body wants to get rid of that heat, and it's having a hard time getting rid of that because there's so much water vapor in the atmosphere. So how the air mass behaves often affects the human body a little bit differently. That's why people say, wow, gee, you come out here in the middle of winter, it's not so bad, it's a dry cold. And in lots of parts of the Intermountain West and the Great Basin, it is dry because the relative humidity is only 10%. And it could be 10 degrees outside, and you're not all that uncomfortable. But if you're in an area along the coast where it's 40 degrees and the relative humidity is 80%, it's cold. It feels damp cold to you. Conversely, in the heat, that's why Hawaii, which never gets much above about 85 or 88 degrees on the warmest, rarely ever gets that hot, except way up in the mountains and some of the other climate zones. But there's enough relative humidity to keep it kind of balmy. But you'll never feel that way in Las Vegas, because at 88 degrees, it's no big deal. At 100 degrees, it's hot out there, but yeah, it's not like it is in New Orleans at 85 degrees and humid, because the relative humidity is less than 10%. It's dry heat. So all of that relates to how the water vapor is actually moving around all the time, or is in different places of the planet. And what happens when you have that warm water off the coast of South America, the El Nino, that puts a lot more water vapor up into the mix. There's a natural transition that Earth does, is to move that water from the tropics, where there is typically a lot more water vapor coming up in that warm air, and push it up into the mid-latitudes. Then you can move it around and get it somewhere across the ocean, ultimately wrap it up into a low-pressure trough, make some clouds out of it, and get some rain going. That's the process that gets enhanced by that. In other words, you would still have to have the storm you would have had anyway. Now you've got more water in the storm. But it still doesn't lead to, my God, it's going to land on California. My God, it's going to land on my house. I've got to take care. Not necessarily. Earlier this season, there were plenty of floods in Texas and Oklahoma. And then that whole line moved all the way into the Mississippi River, and St. Louis had to go 14 feet above flood stage. And much of the Midwest picked up some weather. And now we just had this big, huge blizzard, nor'easter. Nor'easters happen all the time. But this one seemed to be juicier than most. Is that because of El Nino? Maybe, maybe not. Same thing with the fact that we have global climate change. Weather and climate really are two different things. Weather is the short-term effect. Maybe out to about 10 days. That's what you see in the sky, what comes in over your head, what makes it feel hot or cold or sticky or dry. All of that is weather. Climate is the longer range impact. And the larger the area you're talking about, particularly something as big as the globe, the more time and the more distance you have to factor into the equation. So the El Nino has been putting water vapor up into the northern latitudes since last summer. And at one point, we could show you satellite pictures, there were 3 full-blown hurricanes between Mexico and Hawaii. Boom, 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 lined up like sailors heading out to sea, just ready to go. And all summer long, storms formed close to the Hawaiian Islands, and then moved on up into the northern hemisphere. All of that is that water vapor being moved. And as it happens, nature doesn't sustain that. That's why there isn't an El Nino storm. There isn't a big glob that forms off the coast of Peru and then gets moved all the way up to somewhere in Texas or somewhere in California. It gets broken up into pieces. The water vapor becomes mid to high level clouds. Some of it just dissipates into water vapor until something else converts it back into clouds again down the line. And that's what we're looking forward to. That's why El Nino years for California typically get most active between January and about April. Our rainy season runs from about mid-October to about mid-April. We're a Mediterranean climate out here, so it's vital that we get this rain at some point because that's when we get it. We don't get a whole lot of rain around these parts in July like you do in other parts of the country. So will California get inundated by it? Maybe, maybe not. Just like your investments in the stock market, past performance is no indication of future performance. Just because you have an El Nino doesn't mean it's going to be like 82, 83, doesn't mean it's going to be like 80, 97, 98. And the funny thing is, some of the worst years that we've had in California with regards to extensive flooding were not even El Nino years. What is more conducive to flooding really is what we call so-called pineapple connection, or the atmospheric rivers. When that happens, if this is the West Coast, you get this fetch of moisture coming up from the tropics. It's almost like a big fire hose. You can see it on the satellite. There's a layer of clouds that extends for thousands of miles out to sea. And along that layer, there's a subtropical jet stream with these little ripples, mini cold fronts you might call them, but they're really not cold fronts because the air masses are not much colder than the one in front of it. But these shortwave troughs, as we call them, ripple in. And wherever that hose is pointed, it starts raining a lot. And it may start up in Seattle and come down to Portland, come down to Northern California, San Francisco, and sometimes it comes down the Central Coast and down to Los Angeles and San Diego. And how long it stays there is the determining factor. And the biggest floods we had were sometimes as a result of that. Go back to the winter of 95, Mission Fields, Carmel Valley. We had a period of rain where it was just coming down in buckets, one wave after another, usually within a day to a day and a half in succession. And it would taper off a little bit and come back on, taper off a little bit and come back on. We got some pretty good rain down here, but it was raining like cats and dogs up in the mountains. And so what happened is all that water runs down, and it flooded Mission Fields, a neighborhood in Carmel. Once the water seceded, they started cleaning things up and rebuilding and redoing the houses, putting new drywall in. And come February, the rain pretty much shut off. Nothing, practically nothing, less than an inch anywhere. And March said, oh, wait. Nature said, I'm not done yet. Throttle it up. And here came another one of these events that, again, flooded the same neighborhood. And that happened. Well, it wasn't an El Nino year. But we've had El Nino years where we've had a lot of water. But a lot depends on the timing. So far, this winter, we've been pretty lucky. We've been getting these storms about every couple of days. And people sometimes have been saying, well, where's all the El Nino rain? I've not seen any rain. Luckily, most of it's been happening between midnight and daybreak. So a lot of people slept through all of it. And the first few storms were just about right. You know, half an inch of rain down here in the valleys, inch, maybe an inch and a half up in the mountains. No big problems. Not a lot of wind. Now they're getting stronger. Now you're getting into the colder part of winter. See, our calendar is about 2 to 3 months out of sync with nature's weather calendar. That's why a lot of times people say, oh, this is weird weather. Look at this is October and this is doing that. Now it's January. Look at this. That's because nature reacts slower than we do. We just turn the page. Okay, we got October. Here's November. But sometimes nature says, oh, it's getting a little colder now. Maybe I ought to be doing this. And then, oh, now it's December. It's colder yet. I should be doing this. And it goes on from there. So there's a reactive component in that. And sometimes your winter, as we perceive it, is delayed. Other times it comes early. Last year in the East Coast, they started with the cold storms much earlier than they did this year. But as you probably heard, it wasn't up until a week or two ago. They were still walking around Central Park in New York in short-sleeve shirts going, hey, this is kind of nice. But, you know, now they pay the piper. So now that it's been closed for remodeling, they'll come out about Tuesday and see what's going on. But this El Nino thing may still impact our weather. And again, it depends on the timing. The last couple of storms have been a little stronger, a little wetter. And they may well come to the point where they start packing in a little closer. And it could happen in February or March where you get a low-pressure system that isn't progressive. In other words, it doesn't come through, throw a cold front, throw a bunch of showers, and move on through. And then a high-pressure ridge builds in and dries out. That's all nice. That's actually a good way to do business. The folks in the Sierra are happy. They got a bunch of snow. We're well above normal snowpack. We're well above normal rain for the season to date right now. And we've had time to let it soak in. Because with 4 years of drought, that's where you want it to go. They got plenty of water out there in the Pacific. And if you get too much too fast, that's where it goes. It runs right down the river, right out to the mouth, and boom, out back in the ocean, and we get no long-term benefit for it. So we're gradually trying to fill this up. Even a good El Nino year, if we can make 150% of normal in the next 2 or 3 months, we're going to have a good winter, and it'll help, but we'll be a long way away from solving a drought. You don't clean up 4 years of dry in 1 year, nor would you want to. If you did that, you would have to put down 60 inches of rain in San Francisco alone, to say nothing of what you do up in the mountains. I've seen 60 inches of rain up in the Santa Cruz Mountains over the years, and that is a lot of water. If you were to duplicate that, double it, in 1 year, forget it. Half the people's houses would float down the hill. I mean, that's just too much water too fast. So El Nino is just one of many contributing factors in the climate. It will eventually wear down, and the waters will begin to cool, and ultimately the warm water moves to the western Pacific, and then we get what's called a La Nina, which is the opposite of it. Other times it neutralizes, it just spreads out over the whole Pacific, and it's pretty much normal. So it hangs on. And then other elements may impact the climate. And we're seeing changes in the climate, of course, because the whole Earth is warming. As you probably know, this last year, 2015, has been declared the warmest year ever recorded. And that's in succession to previous years. The change of the climate and the average temperature, there's two differences. Global warming is the average temperature of all of Earth. Okay, you add all the stations, divide by as many stations, that's the average temperature. That fluctuates only about 4 or 5 degrees Celsius. Global climate change is the result of that warming. And we see that in the form of glaciers melting and sea levels slowly beginning to rise, and changes in the weather patterns, where this thunderstorm that came over Oklahoma would have probably developed anyway and dumped 4 or 5 inches of rain. Now we're seeing those storms forming, and they're dumping 8 to 10 inches of rain. I don't care where you live. If you get 10 inches of rain, you got a problem. That's a lot of water. And Oklahoma, they don't got a lot of hills there. It's all kind of flat. And so now we're seeing the same thing with snowstorms, because sometimes you have these situations where people can't put 2 and 2 together. Like, I can't even remember who the senator or the congressman was, and he showed up with a snowball in Congress and said, look, there's no such thing as global warming. And my way of thinking, they should have written "I'm stupid" on his forehead, because he's not making the right connection. Just because there's global warming doesn't mean everybody gets 75 degrees and sunny all the time. It means the average temperature of the planet is warming up. But nature still tries her best to keep that balance, to keep that hot and the cold and the wet and the dry. Somebody is going to get warmer than normal, probably hotter than normal, probably for a longer time. Somebody else is going to get more snow than they've had in a long time and be freezing their butts off for a much longer period of time. And that we will start to see more and more of over time. But it doesn't mean that every weather event has to do directly with El Nino or the global climate change or the global warming. But they are making some connections to some of this that say, yep, that's probably been a contributing factor. Every one of these storms that we see, people go back, climatologists look at, and they try to put all the elements together. And, well, Europe had a real cold winter a couple of winters ago, but it wasn't really because of the climate change. It was just that time to get that cold winter. So when you hear about all this talk of El Nino that's going to jump on your house and flood you away, don't get too scared. Take precautionary measures and, do like a lot of people are doing. Prepare for it. It never hurts to be prepared. And that way you are ready when things happen. But don't be disappointed if it doesn't happen on your house. Probably somebody else is getting real wet. All right, that's it. El Nino. Thank you all very much. I appreciate your time and attention. I hope you enjoyed the graphics. Thank you.